Hi, we're here with Mark Page from DZYNE, and Mark is going to tell us a little bit about a concept you see here up behind us. Mark, I would describe this as almost a helicopter, but with props on its prop.
That's exactly right.
How did you come up with this, and what's the point of it?
So this airplane's called rotor wing, and the concept is to combine the best that you get from an airplane for efficiency and endurance with vertical takeoff and landing. And a lot of people have been trying to crack that nut, as you can see here in this display. What we did was we had done a study where we were trying to do a hybrid system, one that had electric power for vertical takeoff and one that had efficient gasoline power for long endurance flight. And when we got the result, we found that, wow, the rotor that the electric motor wanted was the same span as the wingspan the airplane wanted, and the power for the rotor motor was the same power that we needed for long endurance flight. And we said, well, this is silly. Let's make the rotor and the wing one. Let's make the motor one, unitize them, and find a way to deliver the power to that rotor. And so what we've done is we've put the engines on the wings, we tilt the wings to convert them to a rotor, and we power the wings directly by the thrust of the propellers. So there's no gearbox, there's no torque to ground, as we say, there's no tail rotor, there's no D-spin. So you just use the same engines you'd use for efficient long endurance flight is enough to lift the airplane up when you use the full wingspan as the rotor.
Tell us again why you don't need something like a tail rotor for stability. That sounds like you're doing a moment-to-moment stability calculation.
And in fact we are. So the airplane doesn't have a traditional helicopter's cyclic head, which changes the incidence of the wings on the fly. What we do instead is we have the trailing edge flaps, the ailerons. We manipulate those once per rev to get cyclic, and then we collective, we move them all together, much like a helicopter in that sense. And the reason we can do that is that this very, very large diameter rotor is spinning very slowly. So on a full-size machine, it's rotating at about 1 rev per second. Very, very slow compared to a helicopter. On our small-scale model that we're doing the testing on, it's about 1.5 to 2 revs per second. So it's very slow rotation, and then the flaps can keep up and do all the control you need.
You don't use any gearboxes in this. Can you tell us a little bit about the motor technology you're using?
So we have a demonstrator we're flying now that's electric, purely electric. As an electric airplane, this is also very interesting because it's still very efficient in cruise compared to a helicopter. So with traditional battery technology, nothing exotic, we can get 4 hours of endurance as an airplane and take off and land vertically. So that's pretty extraordinary for present day, nothing fancy battery technology. As a gas airplane, what we do is we use conventional gas engines or even turbine engines. Now the engines are spinning, so they're exposed to some greater accelerations. But these accelerations are actually quite small compared to the beating that the engines take in their normal operation internally. So the accelerations are quite low, for example, compared to what the piston and the crankshaft sees. So with a little bit of adjustment in the oil distribution system, we can take any engine, put it out on the wings, spin it up, and it's, in that sense, it's very, very conventional.
The electric motor technology used, is that off the shelf, or is it DC brushless, or just tell us a little bit about it?
It is indeed. Brushless is what we use, and most everyone is using these days because of its efficiency. It also has some advantages in self-cooling and so forth. So we do use brushless DC electric motors, and although I will say we don't need anything exotic or special, just the same motors you would use for an airplane with that wingspan and that weight.
Great. That's interesting technology, Mark. Thanks for taking us through it.
Well, thank you.